In the spring of 1967, over the mist-covered hills west of Hanoi, Captain James R. Caldwell believed he was flying the most powerful fighter aircraft ever built. The F-4 Phantom II beneath him was loud, fast, and overwhelming, a twin-engine monument to American industrial confidence. It carried more electronics than some World War II bombers, more thrust than anything the Soviets had fielded a decade earlier, and enough missiles to dominate the sky beyond visual range. Or so the doctrine said. What the doctrine did not account for was silence. The radar warning receiver screamed only for a second. Then the world exploded into fire and vibration. A surface-to-air missile detonated close enough to shred the Phantom's right stabilizer. Caldwell fought the controls, the aircraft rolling violently as hydraulic pressure bled away. His backseater, Lieutenant Mark Doyle, shouted damage reports that dissolved into static. The Phantom was dying, but it was not dead. Caldwell made a decision that would change the fate of the aircraft and quietly alarm three nations. Instead of ejecting, he turned west. The Phantom limped across the Red River at treetop altitude, engines howling unevenly. Fuel was bleeding. Controls were sluggish. Every warning light glowed like a verdict. But the F-4 was built to absorb punishment, and it obeyed him just long enough. Caldwell aimed for a dry stretch of farmland near the Laotian border, flared hard, and slammed into the ground. The aircraft skidded, tore through brush, and came to rest in a cloud of dust and steam. Caldwell never saw the men who pulled him from the cockpit. He woke days later in a hospital in Hanoi, his war effectively over. The Phantom, however, had only begun its journey. North Vietnamese engineers arrived at the crash site within hours. What they found stunned them. The aircraft was damaged but intact. The radar nose was cracked, one engine destroyed, but the airframe remained structurally sound. More importantly, the avionics bays were largely untouched. This was not just wreckage. It was a gift. Within weeks, the Phantom was disassembled under camouflage nets and transported by night to a secure facility outside Hanoi. Soviet advisors examined it briefly, cataloged its systems, and sent coded summaries to Moscow. But the North Vietnamese leadership had another idea. China had been watching the American air war closely, not from the cockpit, but from the shadows. By late 1967, relations between Hanoi and Beijing were complicated but functional. The Chinese People's Liberation Army Air Force had pilots, engineers, and an intense interest in Western aviation technology. What they lacked was access. The Phantom solved that problem. In a move never acknowledged officially, the North Vietnamese agreed to transfer the captured F-4 Phantom II to China for evaluation. It was dismantled again, loaded onto trucks, and moved north under extreme secrecy. By the time American intelligence realized something unusual had happened, the aircraft was already crossing into Yunnan province. It arrived at a secluded airfield used for experimental testing, far from prying eyes, far from diplomats. The Chinese officers who first saw it were unsettled. The Phantom was enormous compared to their aircraft. Wide, aggressive, almost brutish. Twin intakes like open jaws. It looked less like a fighter and more like a flying power plant. One engineer reportedly muttered, "This is not an airplane. This is a factory with wings." They began their examination slowly. Every panel revealed complexity. Bundles of wires, redundant systems, backup systems for backup systems. Radar components that required climate-controlled conditions, missiles that depended on precise calibration, maintenance manuals thicker than anything they had seen before. The Americans had not built a fighter, they had built an ecosystem. For weeks, Chinese engineers worked with translators, poring over English-labeled diagrams, reverse engineering logic they had never encountered. The radar alone took teams to understand, not because it was elegant, but because it was exhaustive. It tried to do everything: detect, track, prioritize, assist the pilot, compensate for error. One senior engineer wrote in a classified memo, "This aircraft assumes unlimited resources. It assumes perfect supply lines, rested crews, and ideal conditions. It does not expect failure. It attempts to prevent it." Then came the decision that shocked even the Soviets. They would fly it. The Phantom was reassembled with replacement parts scavenged, improvised, or fabricated locally. One engine was replaced with another, damaged but functional unit. Systems were simplified where possible. Entire subsystems were bypassed when their purpose could not be maintained. By early 1968, the aircraft stood on the runway again, not as the Americans had designed it, but as the Chinese had forced it to survive. The pilot selected for the test flight was Major Liu Wenqiang, a veteran instructor with thousands of hours in MiG-derived aircraft. He had never seen anything like the Phantom. Its cockpit overwhelmed him. 2 seats, countless switches, English warnings everywhere. The aircraft felt less like a weapon and more like a negotiation. As the engine spooled up, the ground shook. Liu noted one thing immediately. This aircraft did not leap. It accelerated with mass, with momentum. It demanded runway. It demanded patience. When it finally lifted off, it climbed like a loaded beast, powerful but heavy with intention. In the air, Liu felt both awe and discomfort. The Phantom was stable, brutally stable. At speed, it felt invincible. But every maneuver carried inertia. Nothing happened quickly. Everything required planning. After landing, Liu removed his helmet and spoke only one sentence to the engineers waiting for him. This aircraft is designed for a war that assumes control. That observation would echo far beyond the airfield, because what the Chinese were beginning to understand was not how the Phantom flew, but why it flew the way it did, and why, in the kind of war unfolding in Vietnam, that philosophy might be its greatest weakness. The second flight was not about performance, it was about understanding failure. By mid-1968, the captured Phantom had already logged 7 short sorties over the test range in southern China. Each flight was carefully planned, deliberately constrained. No missiles, no radar-guided intercepts, no attempts to use the aircraft as it was intended by its creators. Instead, the engineers wanted to see what happened when things went wrong. They began removing assumptions. On the 8th flight, they disabled one redundant hydraulic circuit. On the 9th, they simulated degraded radar input. On the 10th, they restricted fuel flow to levels that would have been unacceptable in U.S. operational doctrine. The Phantom flew anyway. That disturbed them. Major Liu Wenqiang noted that the aircraft seemed to resist collapse through sheer excess. Where Soviet and Chinese designs simplified systems to avoid dependency, the Phantom buried dependency under layers of compensation. When one system failed, another quietly took over. When 2 failed, a third intervened. The aircraft was less a fighter and more a self-correcting organism. But that resilience had a cost. Turnaround time stretched into days. Maintenance crews required constant reference to manuals. Components could not be accessed without removing others. A single damaged connector could ground the aircraft indefinitely. Every solution created 3 new problems. One engineer summarized it bluntly. This aircraft does not forgive ignorance. The Chinese Air Force was built around forgiveness. Pilots rotated quickly. Mechanics were trained broadly, not deeply. Aircraft were expected to operate from damaged runways in poor weather, with limited fuel and exhausted crews. Their fighters were blunt instruments by design. Easy to fix, easy to fly, easy to replace. The Phantom was none of those things. In mock engagements against local aircraft, the Phantom dominated beyond visual range. Its radar, when fully operational, could detect targets long before it could be seen. In theory, it could kill without ever entering a dogfight. But the engineers understood something crucial. Theory assumed preparation. In close combat, the story changed. Forced into turning engagements at low altitude, the Phantom's weight became evident. It bled energy quickly. Its large profile made it visible, predictable. Against smaller, lighter fighters, it needed space, time, and coordination. And those were luxuries war rarely provided. Chinese doctrine officers observed quietly as Liu described the aircraft's behavior. One comparison came up repeatedly. The Phantom fought best when the battle followed rules. Rules of altitude, rules of timing, rules of logistics. Remove those rules, and its advantages dissolved. A classified briefing circulated within the PLA Air Force under a neutral title, Observations on Foreign Heavy Fighter Design. Its conclusions were careful, but unmistakable. The American aircraft represented a philosophy of dominance through control. It assumed command of the air, uninterrupted supply lines, trained specialists at every level. It was devastating when those conditions existed. It was vulnerable when they did not. One paragraph stood out. This aircraft is not designed to endure chaos. It is designed to prevent chaos from occurring. When chaos is imposed externally, the aircraft compensates until its complexity becomes its weakness. By late 1968, Soviet advisors requested access to the Phantom. The Chinese allowed limited observation, but withheld full documentation. Relations between Beijing and Moscow were already strained, and the aircraft had become more than a machine. It was leverage. The Soviets, after brief inspection, were unimpressed. Too heavy, too complex, it's too dependent. They dismissed it as a product of American excess. The Chinese did not. They saw something subtler. They saw an aircraft that revealed its enemy's expectations. The Phantom expected wars to be short, decisive, technologically controlled. It expected the pilot to be a system manager, not a hunter. It expected maintenance to be flawless and logistics infinite. Vietnam was proving those expectations wrong. Reports from Hanoi confirmed it. American aircraft were powerful but fragile in aggregate. Losses were not just from combat, but from wear, maintenance delays, and operational exhaustion. Every sortie required enormous effort to sustain. Meanwhile, simpler aircraft continued to fly. Not better, not safer, but longer. In one internal meeting, a senior Chinese strategist asked a question that silenced the room. What happens when a weapon is too advanced for the war it is fighting? No one answered immediately, because the answer was uncomfortable. By early 1969, the Phantom's flights became less frequent. Spare parts were exhausted. Systems degraded beyond safe limits. The aircraft still flew, but barely. It had become what it was never meant to be, an aircraft without its ecosystem. On its final flight, Liu Wenqiang brought it back with one engine surging and half the cockpit dark. He landed hard, stepped down from the ladder, and placed his hand on the fuselage. This aircraft, he said quietly, is very brave. It was not praise, and it was pity. The Phantom was grounded permanently shortly after. It would never fly again. It was disassembled one final time, its components distributed to research institutes, its lessons absorbed silently into doctrine and design. No announcements were made, no trophies displayed, but the impact remained. Because the Chinese had not learned how to copy the Phantom, they had learned why they should not. And in that understanding lay a realization more dangerous than any stolen technology. That wars are not won by the most advanced machines, but by the machines that continue to function after the plan has failed. By the early 1970s, the captured Phantom no longer existed as a single aircraft. It had become diagrams, reports, marginal notes, and arguments whispered behind closed doors. Its fuselage panels were stored in separate warehouses. Its radar components were sealed in crates marked only with numbers. Its cockpit instruments were studied by engineers who had never seen the plane fly, but who understood precisely what it represented. A confession, not of weakness, but of intention. The Chinese aviation establishment did not publish its conclusions. It did not announce reforms. It did not acknowledge the Phantom at all. But quietly, over the next decade, changes began to appear. Design requirements were rewritten. New aircraft proposals were rejected not for lack of performance, but for excessive dependence. Engineers were asked not only how a system worked, but how it failed, and how it could be ignored when it did. Redundancy was allowed, but only if it did not require expertise to maintain. Complexity had to justify itself in mud, darkness, and exhaustion. The Phantom had taught them that superiority was fragile. One internal memo summarized the lesson in a single line. An aircraft that requires perfection will die in an imperfect war. Meanwhile, across the Pacific, the United States Air Force struggled to articulate why its most advanced fighters had not delivered the decisive dominance promised by theory. After-action reports from Vietnam were dense with data, but thin on clarity. Pilots complained of rules of engagement, of unreliable intelligence, of aircraft that were magnificent in isolation and burdensome in reality. No one mentioned the Phantom's philosophical vulnerability, because to do so would require questioning the foundation of American military-industrial thinking. The Phantom continued to serve. It flew in new conflicts, under new flags, upgraded, modified, modernized. It was never a failure in the conventional sense. It remained fast, powerful, and lethal. But it also remained expensive, demanding, and dependent. Everything the Chinese had observed remained true. Years later, a U.S. intelligence assessment, partially declassified, heavily redacted, would note with mild surprise that Chinese fighter designs did not attempt to replicate American avionics density or multi-role complexity. Instead, they emphasized survivability, ease of maintenance, and rapid sortie generation. The analysts called it a limitation. They were wrong. The Phantom's true legacy was not what it could do, but what it revealed. It revealed that American air power was built on the assumption of control, control of airspace, supply, time, and escalation. When those assumptions held, the system was unbeatable. When they fractured, the machine strained against its own brilliance. The Chinese understood that fracture. They had seen it in Vietnam, not from the cockpit, but from the margins. They saw how even the most advanced aircraft could be neutralized, not by superior machines, but by persistence, denial, and exhaustion. The Phantom had arrived in China as a trophy. It left as a warning. In the late 1980s, long after the aircraft itself had been reduced to scrap and schematics, Major Liu Wenqiang, now a senior instructor, was asked by a young pilot what the most powerful aircraft he had ever flown was. Liu did not hesitate. "The Phantom," he said. The student looked surprised. "Then why didn't we build one like it?" Liu smiled thinly. "Because power is not the same as endurance," he replied. "And wars are not won by the aircraft that can do everything, but by the ones that still fly when everything goes wrong." He paused, then added something he had never written in any report. The Phantom was a perfect answer to the wrong question. That, in the end, was the silent verdict passed by a captured aircraft that was never meant to be captured, never meant to fly without its world, and never meant to teach its enemy anything. But it did. It taught them that complexity is a form of confidence, and confidence in war is a resource that runs out. The Phantom was designed to dominate the sky. Instead, it exposed the cost of domination. And long after its engines fell silent, that lesson continued to fly, quietly, invisibly, through every aircraft designed not to impress, but to survive.